Okay, now let's continue with a few more examples of exponential functions. So let's start this one right here with our example one. Y equals 3 to the x plus 2 power minus 3. So our base is 3. So this is going to be a growth function. Let's identify h and k. H is negative 2 because it's x minus h, and k is negative 3. So our key point is, since it's a growth function, h, k plus 1, and negative 3 plus 1 is negative 2. I'm going to jump down here and talk about our asymptote right now. Our asymptote is y equals k, y equals negative 3. And our domain for any exponential function goes from negative infinity to positive infinity. And our range is going to be everything above this horizontal asymptote of y equals negative 3. So our range is from negative 3 up to infinity. Now, if we want to get a few more points on there, I'm just going to come over here and make a little table right now. We know that our key point is at negative 2. I'm just going to try, I want to make sure when I plug that in. If I plug it in right up here, negative 2 plus 2, that's 0 power. 3 to the 0 power is 1. 1 minus 3 makes negative 2. Excellent. When we plug in negative 2, we actually do get out negative 2. That's our key point. And let's try a point to the left. Let's do 2 points to the left and 2 points to the right of that. If we plug in negative 4, negative 4 plus 2 is negative 2. 3 to the negative 2 is 1/9. 1/9 minus 3 is negative 2 8/9. Whereas a decimal, it's about negative 2.89. If we plug in negative 3 plus 2, that's a negative 1. 3 to the negative 1 is 1/3. 1/3 minus 3 is negative 2 2/3, or about negative 2.67. If we plug in negative 1 plus 2, that's 1. 3 to the first power is 3. 3 minus 3, that's 0. And if we plug in 0, 0 plus 2, that's 2. 3 to the second power is 9. 9 minus 3 makes 6. So this gives us good points to go ahead and plot. Now we had already said that our asymptote was going to be at y equals negative 3. And our key point, negative 2, right here. And then those other points that we plugged in just to make sure, negative 4 on a negative 2.89. That's pretty close down here to the negative 3. Negative 3, negative 2 2/3. Negative 2, negative 2. Negative 1, 0. 0, 6. So we get that our graph here along that asymptote, and then we try to connect and make that smooth curve when we can. Sorry, I'm a little bit off there. Make it go through that point right there. I got a little messy at the end. Sorry about that. There we go. That is our example 1. Let's take a look at example 2. Y equals 1/2 to the x plus 3 power plus 2. Our base here is 1/2, so this is a fraction. When we raise fractions to bigger and bigger powers, then our graph is going to get smaller. This is a decay function, and our basic graph is going to look something like this. Let's find our h and our k. H is negative 3. K is 2. So our key point is h, k plus 1. And our asymptote is y equals k. Domain for any exponential function goes from negative infinity to infinity, and our range goes from k to infinity. Now if we plot these points, we would have our asymptote is at y equals 2. Our key point is at negative 3, 3, which is up here. We know basically what's happening based on the fact that we've got a fraction here. This is a decay function. We know what our general shape is going to look like. Let's plot a few points around there just to get those other values. Let me give myself a little more room there. Let's see, let's pick the numbers -5, -4, -3, -2, and -1. So if we plug in a -5, -5 plus 3 makes a -2. 1/2 to the -2 power is 1/2 to the -2, that's 4. And 4 plus 2 makes 6. If we plug in a -4, -4 plus 3, that's -1. 1/2 to the -1, that's 2. 2 plus 2 makes 4. If we plug in -3, -3 plus 3 is 0. 1/2 to the 0 power is 1. 1 plus 2 gives us 3. If we plug in -2, -2 plus 3, that's 1. 1/2 to the first power is 1/2, plus 2 makes 2.5, or 2.5 if you prefer. And -1, if we plug in -1 plus 3, that's 2. 1/2 to the second power is 1/4. 1/4 plus 2, that's 2 and 1/4, or about 2.25. So that when we plot these points, -5, 6, -4, 4, -3, 3, that's our key point, 1 unit away from our asymptote, -2, 2.5, -1, 2.25, and we do see what's happening here. These values are getting lower, they're getting closer and closer to our asymptote of 2. So our graph looks like this, approaching that asymptote but never quite reaching it. And our third example, y equals -2 to the x minus 1 plus 4. All right, our base here is 2, but we have to pay attention to this flip. This negative right here means we are going to flip. Instead of having a function that looks like this, then we are going to have a function that looks like this. And I want to rewrite it just because I want to make sure to point out this is not -2 that we're raising to different numbers. This is the opposite of 2 to the x minus 1 plus 4. Students sometimes mess up on that and they try to make it a -2 raised to that power, but it's 2 to the x minus 1 power and the opposite sign of that. So this is going to be a decay function because we have a negative. Let's find our h and our k. Our h is 1 and our k is 4. So our key point, remember that since we're having a decay function, our key point is h, k minus 1. And our asymptote is still y equals k. Domain for any exponential function goes from -infinity to +infinity. And the range, since this is a decay function, is everything below the asymptote of y equals 4. So below it goes from -infinity up to 4. Now when we plug in some values over here, let's see. Let's try a -1, a 0, a 1, a 2, and a 3. When you plug in -1, that's -1 minus 1 makes -2. 2 to the -2 is 1/4. The opposite of that is -1/4 plus 4 gives us 3 3/4, or 3.75. If we plug in 0 into our function, 0 minus 1 is -1. 2 to the negative first power is 1/2. The opposite of that is -1/2 plus 4, which makes 3.5, or 3.5. If we plug in 1, 1 minus 1 is 0. 2 to the 0 power is 1. The opposite of that is -1 plus 4, which is 3. If we plug in 2, 2 minus 1 is 1. 2 to the first power is 2. The opposite of that is -2 plus 4, which is 2. And if we plug in 3, 3 minus 1, that's 2. 2 to the second power is 4. The opposite of that is -4 plus 4, which makes 0. And we can graph these points now. We already knew that our asymptote was y equals 4. Our key point, 1 unit away from that, is at 1, 3. And these other points that we plugged in, that we plotted over here, -1 is at 3 3/4. 0, 3.5, 1, 3, 2, 2, 3, 0. We could keep on, and these graphs are, these outputs are going to get lower and lower. These will get closer and closer to 0. Not 0, our asymptote, which is 4. So our graph looks basically like this, and then keeps going from there. So that was a few more examples, and we will talk about this some more in our next class.